MozCon. Y'all ready for this? You know I gotta have an intro, come on, man. All right, so there's a lot to talk about, and you guys know if you've seen me speak before that I speak quite quickly. I also have a very deep East Coast accent and kind of a lisp. So take this URL and run with it, and I should have tweeted it by now as well. So this talk is inspired by a series of books by a gentleman named Kyle Simpson called You Don't Know JavaScript. Now, I've been doing SEO for 12 years. I've been a developer for much longer than that. But despite that, I still don't quite feel like I know JavaScript. And so I read these books, and I felt more confident about it. The more I've talked to folks at this event and other events, I realize that a lot of you feel as though you don't know SEO. And so that may or may not be true. But what I'm hoping to do today is give you more color as to what's going on in the background so you can better understand what it is that you're doing. So I've been thinking a lot about SEO. It's something I do pretty often. And I feel like ever since I went to Google I/O that I feel like more of a supervillain than a superhero in SEO. And I know the theme is superheroes, but we're a supervillain up here. So the reason why is I feel as though we are so far behind Google as an industry. Our tools don't work right. We've got the wrong thinking about a lot of things. We're often just wrong about the things that they're telling us and what's actually going on with these algorithms. But I don't think it's for lack of trying. Here's an example. There's a brilliant gentleman named Dave Sotomato who used to work at Distill, and he found this thing recently, the other day in fact, where he saw that Google was actually adhering to the EU country code in hreflang. He reached out to John Mueller. He said, hey, I'm seeing this in the wild. Is this something you guys support? John Mueller says no. 5 minutes later, John Mueller says, wait, it looks like we are. Do you want to run a test and figure this out for us? To which, of course, Dave Sotomato was like, no, that's your job, dog. Like, I'm supposed to be asking you for this information. And then John follows up with like, well, it's my hope, it's my opinion that this is what's happening. Dog, I can't listen to you. You work at Google, you're telling me this is your opinion. Okay, cool. So I can't listen to webmaster trends analysts anymore. I don't even really get that job. It's kind of silly to me. It sounds like they don't know much more than we do. It really makes me miss Matt Cutts. For those that don't know who Matt Cutts is, because he's no longer at Google, he was the head of web spam, and he was the guy that would give us a lot of insight as to what's going on. What you're seeing here in this screenshot is a series of patents with Matt Cutts' name on it. What that means is he was a guy who was committing code to Google search algorithms and such and its systems, so he really knew what was going on. So what that really has made me start to think about is there's a hierarchy to search. There's this bottom layer called information retrieval, which is the computer science behind search. Then there's Google, who has created a better subset of what's going on with information retrieval and dramatically changed that as a field of study. And then there's SEO, the layer of abstraction that we live on, where we don't really know what we're talking about. So if you think about the people at Google, who lives at each stage? You've got the folks that are in the information retrieval stage who are like your Larrys and Sergeys, who fundamentally change the way that people think about information retrieval. Then you've got engineers at Google, people like Anna Patterson and Jeff Dean, who wrote the algorithms that we chase all day. And then you've got people like John Mueller and Gary, who don't really know much, and they live on our stage. So what I think about is that there's 50,000 Googlers. They're not all engineers. I think there was a number the other day that somebody said, I think it was Jono, there's 400,000 of us. We are inherently search engineers. Search doesn't work without us. We need to lean into that and be search engineers and know more about what's happening around us. One of the key things that I think is a problem is vocabulary. There are things that Googlers say that it sounds like they're dancing around our questions, but they're actually being very precise using the language of information retrieval. So having a better understanding of that vocabulary, when you read things like patents or you hear from a search engineer, you would understand what's actually happening. But to bring it back to our layer, there's only 6 non-trivial things that you have to be awesome at if you want to be good at modern search. There is, of course, being mobile first. There's structured data. Those 2 I'm not going to talk too much about. Cindy crushed it on talking about mobile stuff. Speed, Emily's going to crush that. I'm not going to talk too much about that. But I am going to talk a lot about content, authority, and integrated search. So primarily what we're going to talk about today is the computer science behind search and how it works. Now, basically, when you think about an information retrieval system, it looks like this. You build an index, you process the content in that index so you can serve up answers to people's questions or their queries. Now, let's dig into crawling and indexing, at least as we know it, with regard to Google. So the latest thing that they've come out with, where they've talked about how this works, they said, okay, we crawl, we index, and then sometimes we'll come back and render your page if we think we need to. Okay, well, if that's true, one thing that you need to be aware of is Google adheres very closely to HTTP response codes. So if you're not aware of what they all mean, I would encourage you to take some time to research these and understand that it makes a difference what you do with these. But the one that I really want to highlight right now is the 304 response code. The 304 response code means not modified. And so what that means is when your browser goes to a page that it's already seen before that hasn't changed since the last time it came, it won't re-download that. It saves your bandwidth, it makes things faster. Googlebot adheres very closely to this 304 response code. So if you use it, well, what you can do is make more out of your crawl allocation. So that means they won't spend more time crawling pages they've already seen. They'll crawl more pages on your site that are valuable. Botify did a study on this recently. My time says I only have 17 minutes. Botify did a study on this recently where they looked at over 6 billion crawl data, and they found that no one really uses 304s. So if there's one takeaway you take away from me today, and there's going to be a lot of them because it's 217 slides, write this down. I need to figure out how to use 304s on my site. Little known fact about crawling with regard to Google. If you need them to increase your crawl rate, there's a section in Google Search Console where you can reach out to the crawl team and be like, hey, can you ramp my crawl rate up? We just did a migration of some sort. We're going to HTTPS, and they will do it over the next few days. So let's talk a little bit about JavaScript and SEO real quick, because it's been a hot topic for a long time. I've been talking about this since 2011. One of the things that you need to know is the web rendering service, not system, service, is based on Chrome 41. So there's a lot of things that Chrome 41 can't do. I mean, just to give you some context, we're at like Chrome 67 or something at this point. So if you want to audit a JavaScript site with regard to SEO, what you should do is run 2 crawls. One crawl in Screaming Frog, where it's just a text-based crawl. Another crawl in Screaming Frog, which is the JavaScript rendering crawl. And then what you want to do is compare this column here that you're seeing, the hash column. That's a representation of all the content on that page. And if you see that there's any differences between the 2 columns, you have a problem that you want to investigate. You can get even more fancy and create a crawler that works just like how Google does it, using headless Chrome and a tool called Puppeteer. You can also watch a Googler show you how to scrape Google, which is meta and funny. And I would also encourage you to check out this blog post by Stephanie's husband, Justin, about how to audit JavaScript sites. But Google's whole line of how to approach this at this point is by using dynamic serving. They're saying you should do dynamic serving, that's what we want. Dynamic serving can create problems. What dynamic serving means that when Google comes to the site, you serve them a server-side rendered version of the page. When the user comes to the site, you serve them a client-side rendered version of the page. If you're using pre-render I/O, that's what you're doing. There can be problems there where those pages, when they get re-rendered into cache, it can take a long time. Google can see those as 500 errors, and then your page may drop out of the index entirely. So I would still say use a pattern of progressive enhancement. For those that don't know what that is, that means that you have a lowest common denominator version of your content that is whatever you want to use to get ranked. So when a user that does have a client or web browser that can actually see everything, they will see everything. But for someone who doesn't, they'll see whatever you want them to say. But that's all basic stuff that you probably heard someone else say at this point. I think there's a core missing piece here to this process that they talk about, and that's processing. So Google does, and all search engines really, do what's called feature extraction. They identify a page, and then they do what's called sentence segmentation. So they break your copy down into sentences, then we do tokenization, which is breaking them into words, and then breaking those into parts of speech of those different words. Then they'll detect the entities, and then they'll use the entities to determine the relationship of pieces of the content based on the features of those entities. Google's version is a little more in depth, as you might imagine. But another thing to think about is the index is not one thing. When you think about something being indexed, you may have a mental model of it being put into a box of some sort, and then that's it. At the very least, the index is two things. One part is called an index, or inverted index rather, and then the other part is called the doc server. So an inverted index looks like this. All it is all the potential keywords that there can be rankings for, and then there are a series of document IDs, which are representing documents in the doc server with their scores next to them. So when you think of the index, this is actually what you're talking about. But with regard to what is actually there, as far on the doc server side, that's where all the content is stored. That's where all the features of your content is stored. And the interesting thing with regard to the doc server is Google has actually been very transparent about how this works. There's a paper on what's called Bigtable, their data store, which talks about how they store things for pages. And this is a screenshot from that paper that shows you. Interesting thing about this is that anything that they store, they can store multiple versions of it. So as you can see in the screenshot, you see 3 things under content. That's 3 versions of your page that they've downloaded and saved. So think about that for a second. If you want to be a spammer, they index something, and they come back and index it again when you stop being a spammer. That means they have a record of that content forever. Don't spam. So when you look at the cache, I would expect that the cache is the example of whatever the latest version of that content is that they have. And they also have a patent where they talk about how they can re-rank things based on several versions of it. So again, that's how that works based on how they store it. The index is not 2 things. It's actually a very robust system of a variety of different things that happen whenever you put something into it. Google itself uses over 200 microservices to generate your SERP whenever you search for something. What does that mean? That means there are 200 small programs at least that run every time you search to construct that page that you look at. So how does ranking work? Well, basically, you break your content down into a series of features. You score those features using mathematical models, pretty similar to what Brittany described when she was talking about machine learning. And then you also look at other features that they have, topical features. You have features on links, features on anchor text, and so on and so forth. And all of that comprises a score. But don't take my word for it. Listen to somebody from Google.
We find pages that match. We compute a score for the query and the page. And this computing the score is sort of the heart of ranking in a lot of ways. We come up with a number that represents how good a match the query is for the page. Once we have that, we send each shard sends back the top n pages by the score. And it's some small number of pages for each shard. We've got a lot of shards. The central server then combines all the top pages, sorts by the score, and then we're almost done. And then we do some post-retrieval adjustments. And this is looking at diversity by hosts, looking how much duplication there is, spam demotions kick in at this point, and a whole bunch of other phases, little-ish things come in at that point. Then we generate snippets. We've got our top 10. We produce a search result page after we merge with other search features and send it back to the user.
So what we think of as ranking algorithms are called retrieval models. And effectively what happens is you put a query and a document into a statistical algorithm, and then out comes output that we're just talking about. A basic rank scoring model might look like this. Effectively, you're looking at the summation of all the terms, you're looking at the weight of the query term, then you're looking at the document term weight. You can add any other number of features to this type of equation as well. You'll see all types of ranking models that look very different. And in fact, it's usually a function of the document features versus the query features as well. So there's all types of ranking models, just like in machine learning, there's all types of models you can choose from. In fact, there's a lot of overlap between the two. And again, understanding this vocabulary stuff, you can really dig in and find a lot of this stuff just living out there. I was digging into Bing's patents, and I found their ranking algorithm. And the funny thing about it is, what you'll notice right there is there's a feature called WTF, as in who the fuck is using Bing? Oh, snap. So Google has a series of scoring functions. So even if we knew all of the different equations that they're using, it looks like they may try different ones for different queries, or even all queries. So even if we knew everything, we don't know which one they are using at any given time. And to Paul's point, they will also do post-retrieval adjustments. So they may pull back a bunch of pages and you might be in that list, but then you might be demoted for spam or any other number of reasons. They also do a lot in query processing. So to understand what you're looking for, they break it into a series of operations. Again, we talked about 200 plus microservices. Well, that looks about to be 50 or so of them right there. And then query adjustment, they will take your query and say, okay, maybe what you meant is this rather than that. I don't know if this is the Hummingbird patent, but it sounds very similar to what they do there. Google uses what's called multimodal search. So multimodal search means that using implicit and explicit context about you when you perform a search informs what they're going to give you back in your rankings. They also will build a model of you based on the things that they've stored over time. This is specifically a white paper around personal assistants, things like Google Home. But they've also got some patents that speak to what are they storing. So look at that. You see things all about like the click events, what type of results you clicked, what type of operation you did, what was your IP, what was the timestamp, and then you got a section called derived data. So that means they're taking some of those features and figuring out new things about you that you haven't told them. With regard to queries, queries become entities so they can leverage those relationships and the data about these entities in giving you the right answers. Another interesting thing that I found in all of this research that I've done, we all know, or some of us may know, Google has a 32-word limit on any query that you do. So that may be an indication that in these inverted indexes, or indices, they only go up to 32 words that they would store. So with all this complexity, how do we beat the robots? For some of y'all that only saw Infinity War, I'm completely giving away what's going to happen next. So first thing that you need to be very focused on is hyper-targeted and optimized content. And my timer's at 8 minutes. I don't know how much time I actually still have. So Cyrus Shepard is perhaps one of the biggest gems in this industry in that he's put out so much great content. A couple weeks ago, I made a column in TweetDeck just to follow him, and I was able to like keep up with everything in the space. This is one of the most underrated blog posts that he had written, where he talks about advanced keyword concepts in on-page SEO. And in fact, Steph, when she gave her talk a couple days ago, she touched on this, or she referenced it in her talk. So there are 7 things that he talks about here, one of which is keyword usage. As you might imagine, you might want to use the keywords that you're trying to rank for on the page when you're writing. And the way that search engines look at this is first they will tokenize the page. They will turn it into the different core words on the page and then use those in the scoring, in the statistical model for scoring. They'll also look at this in another way where they'll break them into n-grams. N-grams meaning words of n length. So 1 word is a unigram, 2 words is a bigram, and so on and so forth. It's interesting, Google has a lot of data out there that you can look at these n-grams. They've got a data store that they put out of all their n-grams prior to 2006. If you go to the book viewer, the n-gram book viewer, that's what you're seeing. If you put a keyword in there, the instances or incidences of those keywords across time. They also look at synonyms and close variants. So looking to see if keywords are used together on the same page that are very close. And so a way that you do this in information retrieval is through stemming. So if you use a keyword like love, lovingly, loved, lover, it breaks all of those down into the root of love. And so it helps the search, or it helps the information retrieval system really understand what is this page about. And then there's what's called lemmatization. This is another way to look at the same type of concept, except it looks at the inflected forms of words. So not only is it, the same stem, but words that mean the same thing. Good and better have the same lemma, as it's called. Then there's semantic distant and term relationships. So this is the usage of how physically close words are on a given piece of content. And there's a variety of different theories and concepts in information retrieval that speak to this as well. And I think Brittany mentioned this one in passing, Zipf's law. This is a theory that similarly distributed words will be similarly distributed across documents in the same corpus. Corpus is effectively the list of documents you have to choose from in ranking a given keyword. And then if you apply this, what happens is you'll see that there is a pretty consistent distribution of those keywords. And so when you think about it, there's not going to be a dramatically different set of keywords between a variety of different documents that are looking to rank for the same keyword. One thing that we've talked about a bit in SEO is this concept of latent semantic analysis. This is really turning those keywords into a matrix and then looking for the relationships between them, again, mathematically. Another one that we talk about a lot, and I've talked about a lot as of late, is TF-IDF, wherein you're looking for the importance of different keywords with respect to their appearances in those documents as well. So there's a large repository of content that the right team has put together of how you can leverage this in writing more algorithmically safe or algorithmically relevant content. And then there's phrase-based indexing and co-occurrence. There's a lot of talk about this over the years. This was a key patent that it helped Google get more relevant in their results. And effectively, what you're looking for is words that co-occur with each other when you're looking at content. So as an example, if I want to rank for a keyword like basketball, and the pages that rank well for basketball also have the keywords LeBron James and Philadelphia 76ers and so on and so forth, search engines will expect that I also have those words on my page in order to rank better. Tom Capper made allusion earlier where he talked about this idea of having words on the page, SEO copy, that isn't good enough or is actually hurting your rankings. That is one of the things that phrase-based indexing looks for, bad words that you might be using. And so there's another law from information retrieval behind this called Heap's law, which basically indicates that vocabulary will grow in that corpus at a very consistent rate as well. So again, they're expecting new keywords to come in, but not dramatically different keywords. One of the things that Steph talked about was entity salience. So whether or not these entities are being used within the content, and then again, what are the relationships between them? So they leverage the context of these entities to determine the relevance of that content. There's another concept that comes from information retrieval called hidden Markov models, which basically says that if you're describing an entity but not explicitly naming it, we still assume this content is about that entity. So what does that mean? You don't explicitly have to always say, you know, such and such person when you're talking about them. They find that similar words will get used over time just because it's used to explain the same thing. And then page segmentation is something we've talked a lot about in the space as well, with this idea of Google understanding prominence, where things are on the page, things in the body content being more important than things that are in sidebars and so on. So what does this boil down to? It means that all of us need to be thinking about what Google's expectations are for the content, for the keywords that we're looking to rank for. So I just gave you guys a ton of concepts. How do you actually use this? Well, that's another place where SEO is kind of having shortcomings. There's not a lot of tools that speak exactly or precisely to the different concepts that we just talked about. Now, if you want to get real nerdy with it, there's tools like Nime that allow you to do text processing, and every single idea that we just talked about, there is some sort of model that you can throw your content in and then see how well it does against existing content. Nime is great because it's all drag and drop. They have a bunch of different workflows that you can just say, okay, bring my data in, I want it to do this, 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 and this, and then you get a score at the end. But let's go back to the tools that you know very well. So the first thing you want to do is go into SEMrush, put in your domain, go to the organic research stuff, and then see what keywords don't rank well. Here's an example for Moz. What does SEO stand for? Why does Moz not rank well for that? They rank 86. Okay, well, let's go to the SERP. What do we got? Okay, we got some results. We got a featured snippet. This is your #1 result. Really? Is that your #1 result, Google? Uh-oh. So this is the page that ranks number 86. I'm pretty sure this is a better example, but why is it not ranking better? So let's see what else that we could have rank for moz.com. Well, we throw in a site colon search with the keyword, what does SEO stand for? And we've got other opportunities with regard to that keyword. These are other landing pages that we could choose to optimize. But maybe we're not going to do that. Let's stick with the one that we already see is pretty good. Let's go to a tool called Content Success by Right. And then what we do is we put in that target keyword, and we'll see what the weighting is of those terms that the search engines expect based on what currently ranks. And then we put in our URL, and we see in that green line graph that we're missing most of those terms. So you can see at the bottom of the page which pages it looked at. It's again those URLs we saw in the SERP. And then we can take the copy from that page and throw it into the Content Success tool, and it'll tell me precisely which words I need to use more of, which I should use less of. Now, it's a pretty manual process, I get it, but what I'm trying to say here is content creation does need to become more manual so that we can account for this until SEO has better tools. But the folks at Searchmetrics actually do have a pretty much better tool than that, in that it incorporates entities. It allows you to edit in an editor that looks like WordPress. There's a lot of good stuff there. All right, let's talk about integrated search. So one of the questions that Rand has asked a lot about over the last couple of years is, does Google use CTR? We've all talked about, does Google use dwell time? People ask that question of Gary all the time, and he says precisely, we don't use analytics or bounce rate in search ranking. Because the question was, are you using bounce rate to determine what should rank? And he's right, they don't. And he's trying to be clear that Google is not using your analytics to support this. So the thing to know here is a basic best practice of information retrieval is using what's called evaluation measures. And two of those evaluation measures are CTR and dwell time. Dwell time is a determination of whether or not there was a successful click. This isn't something new. Google didn't invent this. This is how every information retrieval system determines whether or not they're successful. So does Google use CTR? Well, here's another quote from him. He says, we use clicks in different ways. The main things that we use clicks for are evaluation and experimentation. Evaluation is the keyword here. That means they're trying to determine, are these good search results? So there's papers out there where Google talks about query logs and click logs. This is the data that they store whenever somebody clicks on something or whenever somebody performs a query. What's in a query log? Again, IP address, the user that did it, did they stay there? Things like that. What was the query itself? So in watching a lot of these videos, people like Jeff Dean have said, Google will rerun the query logs to see whether or not we're still getting successful results when we change the algorithm. And in fact, they also say query logs are noisy. This is what we hear a lot about. Like, oh, we don't use this all the time because it has bots, it has spam, it has errors, things of that nature. But then you've got a patent that says, hey, we actually do use this. So who are you going to believe? Nevertheless, when you look into how they are approaching machine learning in this context, it's the same sort of idea. You have to have some sort of verifying metric that says, we've done a good job here. But let's bring this all back to what we can actually do. You've seen so many stories and case studies about integrated search being something that gives you a halo effect. More people clicking on your results when you're in both places. Well, another way you can get this is by having more compelling meta descriptions. The folks at Old Spice do a very good job at writing meta descriptions that have the brand voice and tone, also have the CTA in it. But what it comes back to with regard to doing integrated search is combining data from both sources. So you've got data from AdWords, data from Search Console, data from SEMrush, so on and so forth. You want to then combine that and then see what's going on. What's the story? You can get that data from whatever tools you're using, and then you want to come up with a series of business rules that says, hey, we want to bid more here, we want to bid less here, we want to build more links here, so on and so forth. So if you want to capitalize on the fact that Google is using these signals, the best way to do it is to have something that's going to be sustained, not something that's going to be like, hey guys, click on this result, right now because I'm on stage. That's just not going to last. Real quick on structured data. When we talk about structured data, of course you should be doing this, but I don't believe that it's just this. Here's an ICO project I've been working on. What is that SERP feature? What gets me that search feature? I've never seen anybody talk about this before. All that is a table. So any opportunity that you have to really embrace these structural opportunities, I would say go for that. All right, so let's talk about authority real quick. I don't think we've ever truly understood PageRank, because there's been a lot of arguments like, oh, is domain authority a thing? Like, what's going on here? I don't know we ever understood it. And so when we think about the metrics that we're using in all these link tools, they're not real. They're all approximations of what we think PageRank is, and every corpus that we talk about for these different link indexes is very different from what Google has. So you'll find that Google is very adept about thinking about anchor text. They're also looking at your links. Are these links from pages that already rank well for that keyword? That is one of the key things that they look at. And then they also look at, how do we take a quote from this page that's linking to this other page and use that to inform whatever we're doing. So the thing I want you to focus on, because at this point, if you don't know how to do external link building, you're probably not going to figure it out. Think about how you can build more internal links. And so what we found is one of the sites that we work on is a pretty large site. We've done A/B tests and such, where if we build more links to a given page, it drives more traffic, increases rankings, and so on. And so we're also seeing that more internal links, of course, lead to more crawl activity. I would encourage you to compute your internal page rank in a tool like R. Otherwise, use Botify, which automatically does it. Here's an algorithm of how you can, at scale, build out your internal link structure even better using Google's NLP API. So a key thing that we need to touch on here is the understanding of SEO implementation. I think this is a big problem because a lot of the recommendations that we give don't really take into context of what's going on with the website. How's it built? So for instance, when you say, hey, we need to make changes to the HTTP header, that's not something that's necessarily super easy to do because it can be governed by either the server or the program itself. So that may include, making changes to code, making changes to server configurations. Same thing with redirects. That could be on the server level or the application level. So you have to better understand what it is that's going on that governs that so you can make the better recommendation. hreflang requires a very specific data structure on the relationships between URLs. Internal linking structures require you to make changes to many pages throughout the site. That's not something that's easy that you just say, hey, let's change this one line of code. You have to go through on the database level or go through page by page to make these determinations. XML sitemaps also require a data structure of the URLs and their relationship. Speed is a whole other can of worms. If you go and say, hey, let's just get the speed up because Google's patents say things like, we look at speed to determine how things should rank. And we see that when things are faster, they get crawled more, especially for bigger sites. And then you go, hey, we need to improve the critical rendering path because I read it in Google Page Speed Insights. There's all types of problems that you can create by following these things without understanding the context. So you got to understand that you can create race conditions. You can do all types of stuff that break the site if you follow these things without understanding how they work. Now, ultimately, I want us all to be more actionable and optimal. The keys to being actionable is delivering recommendations that are segmented with the crawl. So when you segment your crawl, you have a better understanding of which pages have the problems, and then your implementation folks have a better understanding of how they can fix them. Then, if you segment your rankings, you have a better opportunity of understanding where the opportunity is, and you just have to be far more specific. Here's some scenarios. So, a gentleman like Richard Baxter said, a lot of SEOs don't understand that there are database optimizations that you can make to make the site work even faster. You can do things like look at the code coverage report and see where there's problems in the code that are making things slower. So if your recommendation looks like this, remove unused JavaScript and CSS from all pages to enhance page speed, you're not being specific enough. That's not actionable or optimal. It doesn't tell anybody what to do. Why? Because let's say you're removing things that are unused like Facebook Connect or Google Analytics, and you then put that on the site in a new file, that's going to break the site whenever they make updates to those programs. So try this instead. Be very specific. Say, remove these lines from your code because we're seeing that they're not being used anywhere, and it may be valuable to make things faster. Here's your recommendation. Are you saying, oh, implement HTTP2 to make the site faster? That's not actionable or optimal. You don't know whether or not they have a server that supports that. You don't know if they're on Nginx or IIS or something like that, or you don't know what the configuration is. So you should be very specific. Based on your HTTP headers, it looks like you're using Nginx this version. Here's how you set it up. Your recommendation could be, you've got broken pages throughout your site. We recommend updating those URLs to 301 redirects. Here's a list of one-to-one relationships. That's going to be very slow. It's not actionable or optimal. What you should do is figure out the best way to put these to determine these 301 redirects as patterns so you don't have to go through every single one on every single page load. So you should try this. Say, hey, based on your HTTP headers, we're seeing that you're using Nginx. Here's what you should do in your server config. You have to better understand which environment you're dealing with. And I think I'm out of time, so I'm going to just keep going to the super useful stuff. All right, so figuring out whether or not your stuff is actionable is, can they actually implement this without additional discovery? Is this the best solution or is it a solution? Software testing. This is something that you can put in place so that when your developers are rolling out new stuff, they don't end up breaking your SEO. There's all types of tests. There's integration tests, unit tests, so on. And effectively what happens is when your developers are pushing code, these tests have to pass in order for code to go live. So your process should be, basically you work with your team to develop tests, and then based on those tests, you can then have those things automatically happen whenever they push code. Here's some examples of tests that you can run, but you also may need an internal crawler in order for this to be effective. You can build this with tools like Lambda, so on and so forth, so you don't have to have a server running all the time. Split testing, Distilled has talked a lot about this. They've done a great job. We've got some clients we do this for that allows us to really mitigate the risk of recommendations that we put together. So we had a situation where they had duplicate page types and there's millions of pages that could have lost traffic. We ran an A/B test. We saw that it worked better, and then we moved on and we rolled it out to the entire site. So the first thing you want to do is develop a hypothesis, then bucket your pages. You want 2 A groups and then a variant. And then you want to make sure that you're getting traffic, or crawl activity to these pages so you can ensure that these will actually get crawled in that time frame, and then you'll ultimately get the results. You want to then benchmark that performance, launch your experiment, and then analyze your performance. From there, you also want to use a tool like Causal Impact, which is a library that allows you to measure things. You can also use Profit for predictions. Distilled has a free tool you can use. They've also got an enterprise tool called ODN. And what I'm going to leave you with is how to become a dramatically better SEO. So if you think I did a good job, I don't want to hear you think, oh, Mike, you killed it. That was crazy. I understand search now. No. What I want to hear from you are, what are the 3 things you're going to take from MozCon from this week that you're actually going to implement? And we can talk through how you can actually make those happen. But I would also encourage you to read more on information retrieval. I would encourage you to learn how to set up a web server. I would encourage you to build a website from scratch using HTML, CSS, and JavaScript. And I would encourage you to take that website that you built from scratch and make it rank for 5 keywords. So here's the credits. I'm Zora's dad, Mike King. I'm from a company called iPullRank. We do all these things. Shout out to my homie Rand Fishkin, because it was his birthday yesterday. Enough said. But wait. I got a post-credit scene, y'all. So a couple outreach hacks. We talked about machine learning real quick, you know what I'm saying? So here's a hack that you can use for outreach. Go to BuzzSumo, look for the most popular piece of content that people are sharing on a given site, summarize it, and then reach out to them. You do that real quick, throw a domain in there, and then you put it into a text summarizer so you don't have to read the whole thing, and then you do your outreach. Last thing, you can build a chat bot to automatically overcome objections that you get from people when you do your outreach. So you want to use a tool called Dialogflow, it used to be called API.ai. You build out your automatic responses based on the variables, and then you set it up, connect it to your Gmail using Zapier. And I actually talked to the Pitchbox guys last night, and they're talking about adding this to this software. And that's all I got. I'm dropping the thing.